Okay, everybody, last but not least, number 3, we're going to write a piecewise function for each graph. So letter A, now I've given you the graph and you have to actually write the function. So first of all, you can start with y equals, you can start with f of x equals, you can start with g of x equals. It's completely up to you. I know a lot of times we just like to go with y, and then on this one, I have two different functions. So when I do my little bracket thing, I need to make sure that I'm going to have enough room in there for both functions. Now, these are once again linear, so y equals mx plus b. This is going to be your slope. This is going to be your y-intercept. So if I take a look, and you always start from left to right, just like with quadratics when we did increasing and decreasing, you read it like you would a book from left to right. You always start with the leftmost piece first. Then if there's a middle piece, you do the middle piece. And then if there's a right piece, you do the right piece. Here we have two pieces, so we're going to start on the left, and then we'll do the right. So if I'm starting with my y-intercept, which is usually where I like to start, my y-intercept is going to be up here at 3. I know that the dot is in fact open, but we'll deal with that later. But for right now, it's hitting at 3, so we're going to have a plus 3. Then we have to figure out the slope. Well, the slope is, if you start here, you would go down 1 over 1, down 1 over 1, which is actually up 1 over 1, up 1 over 1, and it is a positive slope. So our slope is just 1. So you would have 1x, but when you do that, you don't really need the 1, so I'd prefer not to see it. So this one is just going to be x plus 3. We're going to put a comma. I'll come back to that in a minute. I usually like to do the functions first. So our second one, also linear, y-intercept is down here at -1. So we're going to have a minus 1. Then we have to figure out the slope. Up 2 over 1, up 2 over 1, up 2 over 1. So the slope is 2 over 1, which means we're dealing with a slope of 2. So 2x minus 1. And then we're going to put our comma. Now we have to figure out those barriers, okay? Like the first one exists only on the left side, the second one exists only on the right side. And if you look at where the split is right here at 0. That is at x equals 0. So it looks like the red one, or the first one, is when x is less than 0. And it looks like the other one is on the other side when x is greater than 0. But then, do you remember that one of these had an open dot and one of these had a closed dot? So this guy had an open dot, so we'll just leave him alone. This guy, on the other hand, had a closed dot, so we're going to come back here and say when it's greater than or equal to 0, and this is your function. Letter C, so I'm moving on to letter C. Kind of the same idea, so let's try this again. First of all, I'll change it up. I'll do f of x this time. Still only 2 pieces, so make sure you have enough room for 2 pieces. Again, left versus right, always start on the one on the left, so I'm going to start over here. It is a line, so once again, y equals mx plus b. Start with your y-intercept. On this guy, it looks like it's down at -1, so I know I'm going to have a minus 1. Slope, rise 1, back 1, rise 1, back 1, rise 1, back 1. So the slope is 1, but you notice it's going the opposite direction this time, and I use that word back 1. So it's really -1. So we've got -x minus 1. Second one, y-intercept is up here at 2, so we know we're going to have a positive 2. Slope, up 1 over 1, up 1 over 1, up 1 over 1, this time going in the positive direction, so positive x plus 2. Once again, if I kind of look at where my boundary is, it's still being split on the y-axis, so that's at x equals 0. Our first blue graph is when x is to the left of 0. And again, that little inequality sign points the direction it is. So that arrow points to the left, and this graph is on the left. The second one is when x is greater than 0, and that arrow points to the right. This is over on the right. Last thing we need to figure out was which one was the closed dot and which one was the open dot. It looks like the blue graph was the closed dot, so I come back to my blue one, I put an equal to sign, and you're done. Last but not least, this one, it looks to me, has 3 parts. So I'll change it up again. Why don't we use g of x? And this time I'm going to make this a little bit bigger because this time I have to fit in 3 different functions. Now, again, if you have 3 parts, you go from left to right. So this one over here has to be first, the middle one has to be second, and then this one over on the right has to be third. So I'm first going to start over here. Y equals mx plus b. And I'm looking, where is the y-intercept? And if you look, this graph stops. It doesn't have a y-intercept, which means we have to go a little bit further. So if I find the slope, and I start here, I go over 1, down 1, over 1, down 1, over 1, down 1, which would actually bring me to a y-intercept of -2. So if you can't see a y-intercept, you have to go find it. In doing that, I also found the slope, over 1, down 1, over 1, down 1, which is -1. So that equation is -x minus 2. Next one. Middle line from here to here. Now, this guy is a line. It looks like a line, but it's actually not a linear function. This is a constant function because it's horizontal, which means we're not going to follow y equals mx plus b. A constant function is just y equals the number, the constant. Some people say that's y equals b, some people say it's y equals a. It doesn't matter, but it's y equals whatever it is. And in this case, y is 2, y is 2, y is 2, y is 2. It doesn't matter where x is, y is at 2. So this function or this horizontal line is just 2. And then we'll have to figure out our boundaries. And then last but not least, let's take a look at this guy. He is a line. So once again, we're going to do y equals mx plus b. If I'm looking for my y-intercept, do you notice once again we don't have it? So we find our slope, down to over 1, down to over 1, which is going to take me right down here to -3. So I'm going to have a -3. And then we did rise to over 1, rise to over 1, rise to over 1, rise to over 1. So our slope is 2x and then -3. Now from here we have to go find our boundaries, and I'm going to erase a little bit so that we can see what's going on a little better. And it looks to me like we've got a couple boundaries. So our first boundary I'm seeing is right here. And the second boundary I'm seeing is right here. So if I'm looking at the blue function, which went out here to the left, that's at -2. And again, these are always x values. So when x is less than -2. And while I'm over here, is this an open dot or a closed dot? It's closed, so I'm just going to add on the equal to sign. Next one is our red function, which was our constant function. And you notice that that guy is actually between -2 and +1. This is over here at 1. So this guy has to be between -2 and +1. You put your x in the middle. When x is greater than -2, when x is less than 1. These are always less than signs. They're both less than. It just depends which direction you read it from. Then I'm going, okay, well, wait a minute, that's an open dot, that's an open dot, so both of those are going to stay just like that. We're good to go. And then last but not least, we've got from 1 out. So this guy is when x is 1 or bigger. So x is greater than 1. And then it's a closed dot, so we're going to make it equal to. And there's our function.